Hello. In this video, we're going to continue our study of radicals. And what I want us to do is figure out where these two graphs intersect. So the first graph here is root x plus 2. The second graph is x minus 4. Well, let's go ahead and do a quick sketch of both of these. Root x plus 2 is going to be a radical shape. We could make a little table here if we wanted. So x and y. You can pick some nice values, so you could plug in 0. Square root of 0 is 0 plus 2, so 2. Square root of 1 is 1 plus 2 is 3. And 4, that will give you square root of 4 is 2 plus 2 is 4. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. 0, 2. 1 and 3. 4 and 4. So there we have our nice radical shape. Over here we have a line. We know it's down 4. So 1, 2, 3, 4. And then it's just going to be over 1, up 1, over 1, up 1, over 1, up 1. Just a simple, nice linear graph. Now those points don't look actually super linear. I think my scale's a bit off. Maybe I'll just draw 2 points. There we go. That looks better. So we have a line and we have a radical. And what we didn't draw, but what kind of looks interesting, is if we extended this radical, I think there's going to be a point where they intersect, a point where the two lines cross. And then, of course, the blue graph will keep going on this way, and the red graph will be here. And I think they're just going to cross the one time. But it's interesting. I would like to know, what is the x value here where they cross? Maybe I want to know over here, what's the y value? And just from my kind of sloppy sketch, I don't think we can figure out exactly where they intersect, but with algebra, I think we can. So let's go ahead and do a little bit of algebra here. We have y equals root x plus 2. We have y equals x minus 4, and the easiest way to see where they intersect is to set their y values equal. In other words, we just make these two equations equal. Now, this is a classic radical equation, and so we want to isolate the radical, isolate the square root. Then we want to square both sides. The square root of x squared disappears. And here we're going to have x squared minus 12x plus 36. Now we have a quadratic, so we want to kick this x to the other side. And now we're looking for two numbers that multiply to give 36 and add to give negative 13. Well, I'm thinking 6 and 6 go to 36, but that's not going to give me 13. Maybe 4 and 9. 4 times 9 is 36. And yeah, if I make both of those negative, that will give me my negative 13. So x minus 4, x minus 9 equals 0. And that's going to give me x equals 4, x equals 9 as my two solutions. Okay, but wait a minute. If we go back on our graph, I guess this one probably does look like x equals 9. And if we check it out, we could plug it in here. So 9 minus 4 equals 5. And over here, square root of 9 plus 2 equals 3 plus 2 is 5. Yeah, so the y value is 5, the x value is 9. So at the point 9, 5, maybe let me just move that over here. Yeah, we've got a point of intersection here at the point 9, 5, right there. But what is happening at 4? Over at x equals 4, the blue graph is going through the x-axis, but I don't think it's intersecting with the red graph at all. We knew the point at 4. When we plugged in 4, root 4 was 2. 2 plus 2 is 4. This point here is certainly not intersecting down here. And so this is kind of strange, because this right here was supposed to be the answer, but actually one of them is false. When we check x equals 9, it works out. But when we check x equals 4, on the one side, we get y equals root 4 plus 2, which is 2 plus 2, which is 4. On the other hand, you get y equals 4 minus 4, which is 0. And so this is not true. This is not one of the solutions. This is like an extra solution, a an extraneous solution. It's not real, it doesn't exist. And I want to show you on Desmos kind of what this looks like. So the way you do it algebraically is you simply solve for x and then you check them both. As long as you do your two checks, you'll find out which one is legit and which one is not. But I just want to show you the visual because it's pretty neat. So if we take a look at the graph here, we can clearly see the point of intersection at 9, 5. But where's the other point of intersection at x equals 4? We actually have to do something interesting here. When we squared both sides, we actually included both the plus and minus version in our algebra. And so if I put the minus here in front of the root x, suddenly another solution just appears out of nowhere. Now again, this solution isn't real because our graph didn't have a negative sign. Our graph looked like this. But you can see how the algebra sort of got mistaken and believed there was a solution here at x equals 4 when there actually wasn't. In cinematography, you could think of this as like a lens flare. So if you're taking a picture or if you're filming a video, sometimes it will look like there's some kind of flare on the lens when you have like the sun or some kind of source of light. And it can cast a really interesting shape or picture on your photo. Let me show you an example. So if you take a look at this picture of lens flare, we have a bright object here, likely the sun. And then we have all sorts of weird things going on. We have these little shimmering rainbows. We have this circular pattern here. We have these sort of look like octagons almost showing up. And none of these are actually real in the real world. They're not there. There's no light source over here. But something's happening with the sensor on the camera. And the light that's coming in through here is somehow with the lens and the sensor is getting distorted and refracted and reflected in weird ways. So these show up. These are not real. There's no UFOs or light sources over here, but the camera sort of thinks there is. It looks really cool as an effect, but we have to be careful because looking at this picture, we might think, oh, look, right here, I have found the existence of aliens. Here's my UFO. And the thing is, well, it's not. It's actually a lens flare. It's an artifact. It's not real. It's simply a distortion. Now, I'm not weighing in here whether there are or are not aliens. I'm just saying that the lens flares can sometimes be mistaken for aliens when it's not actually evidence of them. But let's head on back to the math. Let's look at these two graphs. We have this blue graph, root or 1/2 root x, and we have the red graph, root x minus 6. So this one here is the red graph. Here we have the blue graph. And our question is, where do these graphs intersect? Well, I mean, visually, you might say right here. This is the point of intersection right there. But what is x equal to? I intentionally left off the scale, so we can't see exactly what the x value is. But pause the video and give it a try. See if you can use algebra to determine the x value. Okay, so assuming you give that a try, we should start with root x minus 6 equals 1/2 root x. Now we want to square both sides. So we're going to square here and square here. On the left side, it's easy. It's just x minus 6. But here, we have to square the 1/2 and the root x. So that gives you 1/4 times x. Now, I'm not a big fan of fractions, so I'm going to multiply everything by 4. It's going to be 4x minus 24 equals x. So if I move the x to the one side, it's going to be 5x. Oh, no, that'll be 3x equals 24 minus x from both sides. And then we have to divide by 3. That's going to give you x equals 8. All right, so the answer over here is x equals 8. Now, if you're asked for the x value, you just say they intersect at the value 8. If you're asked for the point where they intersect, well, then we need the y as well. So y would equal root 8 minus 6, which is 2. And it's nice to check right here. We can go y equals 1/2 root 8 in the other equation, right? Plugging it in here. Now, remember root 8 we could write as 4 root 2. So that will be 2 root 2 over 2, which is root 2. Oh, sorry, I left off the root there. So we either get root 2 right here, or we get root 2 over here. and the point is 8 root 2. So this is how we say this is the x value, and or sometimes this could be called, in other words, the solution. And this over here is the point of intersection. All right, let's do another one. So now that we're kind of getting into the swing of things, go ahead and solve this equation, find the solution, find the x value, and then we will compare it with a graph. All right, assuming you gave it a try, we're going to square both sides. 2x squared minus 7 equals 9 minus 6x plus x squared. So if we kick everything to the left side, minus the x squared plus the 6x minus the 9, that's going to give us x squared plus 6x minus 16 equals 0. So thinking about two numbers that multiply to give negative 16 and add to give 6, probably 8 and negative 2 seem good. So x minus 8, x plus 8, x minus 2. Yeah. Because we're going to have 8 and negative 2. So x plus 8 and x minus 2 equals 0. So that means x equals negative 8 and x equals 2. Now again, we have to be careful. Sometimes one or both of these is going to be, again, that artifact, that extraneous root or extraneous solution. So we should check them. So we'll check here. If we plug it in on the left side, we get the square root of 2 times negative 8 squared minus 7. So negative 8 squared is 64. 64 times 2 is 128. Minus 7 is the root of 121, which is 11. If we check on the right side, we get 3 minus negative 8, which is 11. Sweet. Okay, let's check the other one. Square root of 2 times 2 squared minus 7. So 2 squared times 2 is going to be 8. 8 minus 7 is 1. Square root of 1 is 1. Okay, 3 minus 2, that's going to be 1. Oh, okay, well that's kind of interesting. It looks like they both checked out. Let's check this out on Desmos. I want to see what this looks like. All right, so here are two graphs. One of them is a line with a negative slope. The other one is kind of like that square root of a function that we've looked at before. It looks kind of weird, but if you look, lo and behold, there's the point of intersection here where x is 2. So there's a solution at x equals 2. And there's another one over at negative 8. Now you can see those y values that pop up, the 11 and the 1. Those are from the checks. If they're just asking for the x values, we would say here that x equals negative 8, x equals 2. These are our solutions. And they both check out because both of these are points of intersection. So you can indeed have 2 points of intersection. It's possible. And the checking will confirm that. And the graphing just double confirms it. And I think it looks pretty cool, right? If you want to think about this red graph, you can think of this as like you had an initial function, 2x squared minus 7. And then we graphed the square root of 2x squared minus 7. With that, the transformation of like rooting the whole graph, something we looked at in a previous lesson. All right, one last one. Let's solve this radical equation. And there's a lot going on here, so be careful as you get rid of that radical, and then I think you have to get rid of a radical again. So it might require multiple steps of squaring. But pause the video and give it a try. Okay, so we square right here, and that's going to give us 1 minus root 1 minus x equals x squared. Now we want to isolate the root, so I'm going to kick that x squared to the other side and the root to the other side. And then I'm going to square again. 1 minus 2x squared plus x to the 4 equals 1 minus x. Ooh, okay, let's put everything on the left side here. X to the 4 minus 2x squared minus x, and the 1's cancel. I can factor an x out of there. X to the 3 minus 2x minus 1. Now this is a degree 3 polynomial, so it's going to require synthetic. If you thought we were done with synthetic, no, that skill's still useful for the rest of the course. So let's try x equals 1. It's always a nice root to try. So we get 1, 1, 1, 1, negative 1, negative 1. That's not going to work. Let's try negative 1. 1, negative 1, negative 1, 1, negative 1, 1, 0. Oh, sweet. So we get x plus 1, x squared minus x minus 1. And then don't forget we have this x, so let's put that over here. Okay, now, we have a quadratic, so we could either keep syntheticing, but I don't think it's actually going to work. So I'm going to use the quadratic formula. That's going to give me minus b, so plus 1, plus or minus the square root, b squared, 4ac over 2 times 1. That's 1 plus or minus 1 plus 4. So 5. Okay, so we have x equals 0, negative 1. Those are from our first two values here, first two factors. And then 1 plus root 5 over 2, and 1 minus root 5 over 2. Now, I'm not going to expect you to check all of these. There's 4 different answers, and I mean, some of them look pretty gnarly to plug in. Maybe you could check the 0 if you wanted, right? We could maybe check one of these. But this is a bit of an advanced question. So let's take a look. If we check the 0, well, you get the square root of 1 minus the square root of 1 minus 0. 1 minus 0 is 1, square root of 1 is 1. So this should be root 1 minus 1, which is root 0, which is 0. And that would equal, well, the other side would be 0. So yeah, I guess that one checks out. But just for fun, let's look at this on Desmos so we can really explore these 4 solutions. Okay, so here we have the graph, and it's kind of this little wiggly graph. We've got the intercept at 0. There's one point of intersection. We've got a point of intersection at 0.618, and then one at 1. Now, if you were to actually plug these in, you would need a calculator. So I'm going to help you out here. This one is the 1 minus root 5 over 2 solution. So that one checks out, and the one at 1 and the one at 0. But the one at 1 plus root 5 over 2, that one had to be rejected. So 3 of the 4 answers were indeed true. But this one is a bit too challenging, and you would definitely need the graph if you were to do it. I wouldn't expect you to check all of these manually. All right, so let's go ahead and take some notes on this. So here we are solving radical equations. The basic technique is that we isolate the root, square both sides, and then solve for x with algebra. And by algebra, I usually mean factoring, so factoring, synthetic, or even the quadratic formula. Now it's important at the very end to check the solution to see if real or fake solution. I think the technical term is an extraneous root or an extraneous solution, but I like thinking of them as like a real or fake. Like, is it a real solution or is it an imposter? So for practice, you can go ahead here and try 3 equals square root 2x plus 2. All right, so assuming you gave that a try, square both sides, you get 9 equals 2x plus 2. Move the 2 over, divide by 2, and x equals 7 over 2. Now we do our check. So on the one side we get 3, on the other side we get the square root of 2 times 7 over 2 plus 2. Well, the 2's cancel, so you get 7 plus 2, square root of 9, which is 3. So it definitely checks out. Now some students ask me, well, Mr. Peters, isn't the square root of 9 plus or minus 3? And hopefully we've been over this before, but that is not correct. The square root of 9 is always equal to 3 precisely. 100% of the time, and it is never negative. You can try it on your calculator. The square root always gives you a positive number. What you might be thinking of is when we square root an x and we get a plus or minus, but that's when you're solving for an x, not when you're simply plugging in numbers. So the best way to remember it is if you're square rooting an actual number, you always get the positive, always positive 3. You never add any kind of weird plus or minus when you're plugging in actual physical numbers. Now, for practice, you can try worksheet 5 and 5.5. Maybe add a question or two here to your notes. And then any things to remember. And it might be important to remember that if you want the solution, only state the x value. Right? So if you had some graph going on and there was like a radical and there was like another line, and somebody was saying to you, oh yeah, this point is at 3 and 4. What's the solution? The solution is just x equals 3. That 4 is sort of extra information, and we don't want to include it. Although, of course, if they ask you for the point of intersection, you do need both. But the 3, 4 is the point of intersection. The 3 is just the solution, just the x value. All right, hopefully you enjoyed this video. And as always, thanks for watching.